So today we're going to have a look at logarithms and what actually are logarithms. So you should have a good understanding of exponentials now, what an exponent is. Yeah, so logarithms themselves, they can be considered the inverse to an exponent or an exponential. So if you've got 2 to the power of 3, then a logarithm can undo what's happening there, or at least it's an operator that can do that. So firstly, we would consider logarithms as the inverse of exponents. So if a to the x is b, then the log of a, so log is just an operation. That's what we call this. So the logarithm base a of b is equal to x. So notice what's actually happened here. The a stays as what we call the base. So this is the base of the log, or the base of the exponent here. So that stays as the base. The b itself, it was the answer over here, and it is now the number that we're actually concerned about here. So what actually happens here? Well, this is staying, if we take a and we multiply it by itself, x times, so x of these a's, then we'll get an answer of b. And what's actually happening on the right-hand side, the logarithm part, this is basically saying how many times would you raise a to the power? So a to the power of what would give us an answer of b, and it's telling us here that power is x. So it's basically just rephrasing the question, saying, okay, if we've got a number and we want to know, we've got the base a, how many times will we raise this to a power, or what is that number that we need to raise it to get the answer of b? So we're just going to practice using this formula. So have a look at a few examples. We'll go both ways here, and we'll see what actually happens. So our first examples, we want to write these expressions, these equations, as logarithms. So we're going to have a look at each of these, and we're going to write them as logarithms. So in the first one, we've got 2 to the power of 5 equals 32. So let's just consider this over to one side. So 2 to the 5 is equal to 32. First of all, let's just have a look at this. So our base here is 2. That's going to be our a. Our power, our exponent, is x, and then b is over here. What we want to do is just put it into this formula. So this implies that the base is a, that's 2. So we write it as a subscript. And the b itself is just a normal number written in normal script. So the b is the 32. So how many times must we raise 2? So what power must we raise 2 to get the answer of 32? So 2 to the power of what is 32? That's what this question is saying. And the answer here is 5. That was our x. So 2 to the power of 5 is equal to 32. And you'll see why these become important a bit later. So in this one, our base is 10. So we've got log base 10. And then our answer is 1,000. So we're saying here, 10 to the power of what is equal to 1,000, and that's what this is equal to. So the answer here is 3. Give these last two a try on your own. So pause this, give them a try, and then we'll have a look in just a second. So you should have noticed that in this one, the base here is 5, and we've got an answer of 625. So if this was our question, we'd be wanting the answer of 4. Like, we can get it from here, but sometimes we'll be just given this as a question and we'll be wanting to answer that. So the way to think about that is 5. 5 times 5 is 25, times 5 is 125. We times that by 5 again, we get 625. So the answer is 4. And final one, everyone's favorites with binary, we've got log base 2 of 1024, and that's equal to 10. So hopefully you've got a good idea of going from the exponent form into log. Now let's look at going backwards. So the same idea, same formula, we're just going the other way. So sometimes you'll see this written with kind of double-ended implies arrow on it like this. So you can go both ways between here. It's log base 3 of 81. We want to find the value of these. So what is this question? What's it actually asking me? Well, this is stating 3 to the power of something is equal to 81. So I want to figure out what that power is. Obviously, when this isn't whole numbers, then we're in a bit of a problem when it comes out to be decimals, because we're going to need our calculator. But for now, we should be able to calculate all of these. So 3 to the power of 2 would be 9. 3 to the power of 3 would be 27. So therefore, hopefully know that 3 to the power of 4 is equal to 81. So x is equal to 4. Number 2, I'm going to come over to one side because number 2 is actually the first tricky one that we've got. So log base 4 of 0.25. Just take a second, have a think about this, and see if you can work out what the trick is here. So the trick in this one is looking at this 0.25 and thinking, what actually is that as a fraction, first of all? So let's write this as nice numbers. So this is equal to log base 4 of 1/4. Now, a quarter is not really that nice, but we should know that we basically now want to know what is that 4 to the power of what gives us a quarter, and you should, so 4 to the power of what equals 1/4. You should recognize this from GCSE. This would imply that x is -1 because we want the reciprocal of that. If, for example, it was a 16th, then it'd be -2. So just remember, when you're looking at numbers at the bottom, it's got that negative power for the reciprocal. Likewise, number 3 has got its own trick built in there. They're very similar to this one, actually. So for number 3, let's just give myself a little bit of room. So we've got log, I'm actually going to write a half down here of 4, because that might help see what's happening here. So log base a half. This is saying 1/2 all to the power of x, that's our answer here, is equal to 4. So first of all, if x was negative, it would be 2 to the x equals 4. So 2 to the what is 4 is going to be squared. So if I was to square this, I'd get a quarter, but I want to bring the 4 back up. So it's clearly a reciprocal kind of question. So if it was a half, so just consider a half squared, that would give me a quarter. I don't want a quarter, I want the reciprocal of that. So if I made that a negative, then I get the reciprocal of this side, and that would give me 4. So here x is equal to -2. I'll just write that over here. X equals -2. And lastly, this one here, we're going to see in a few different forms, actually. The way we're going to talk about this for now is just what it's actually asking. So this is saying a to the power of what is equal to a to the power of 5. So nice, hopefully a straightforward one. Hopefully you can see here that the question mark must be 5. And we will talk about that a little bit later in the next chapter. So hopefully that's enough to start the first few questions from this chapter. If you've got any questions, just let me know and I'll hopefully cover those. And in the next video, we're going to look at the laws of logarithms. Hopefully that helps. Let me know if not. Thank you very much.